Hello! In this video, we'll learn how to solve problems using quadratic equations. We'll analyze in detail solution of these 7 problems, but before we do this, I would suggest you to pause the screen and attempt to solve the problems by yourself, and only then look at the solutions. We'll start with problem number 1, which is the simplest one, and it says that the width of a PC monitor is 3/4 of its length, and the diagonal of the monitor is 25 inches, and we need to find the length and width of the monitor. In problems, it's always important to make drawings whenever possible to understand what is going on. And if we make a drawing and denote our width of the monitor with x, then the length of the monitor will be 4/3 of x, and the diagonal is 25 inches. So we can see this is a right-angled triangle, therefore we can apply Pythagoras theorem, which means that x squared plus 4/3 x squared is equal to 25 squared. From where we can easily obtain by multiplying both parts of the equations by 9, that 9x squared plus 16x squared is equal to 3 squared 25 squared, or 25x squared is equal to 3 squared times 25 squared. We divide it by 25, and therefore our x squared will be equal to 3 squared times 5 squared, or in other words, our x will be plus minus 3 times 5, which is 15. Obviously, our dimension cannot be negative, so we only leave one solution of this equation. X is equal to 15 inches, which is our width, and therefore our length, which is 4/3 of x, will be equal to 20 inches. You can see that this is not a complete quadratic equation because there is no term with which is proportional to x, so there is no linear term for x. So that's a very simple case. But actually we can solve a similar problem, basically the same, if we formulate it in a different way, and then we will get a proper quadratic equation to solve. So if we say that our length of the monitor is 5 inches larger than its width, and the diagonal of the monitor is 25 inches, it will mean that if our width is x, then our length is x plus 5, and therefore from the Pythagoras, x squared plus x plus 5 squared is equal to 25 squared, and after we open brackets here and sum all the terms with x squared, with x, and the free term, this will be our equation, 2x squared plus 10x minus 600, but it's always good to simplify equation as much as possible, and we see that all the terms here are proportional to 2, so we can divide the equation by 2, and this will be our reduced equation, x squared plus 5x minus 300 is equal to 0. So this is already proper quadratic equation with a linear term and quadratic term and the free term. So we can use our formula for discriminant of the quadratic equation. As you remember, discriminant is equal to b squared minus 4ac, where a, b, and c are coefficient at quadratic, linear, and free terms. So our b is equal to 5 here, our a is equal to 1, and our c is equal to minus 300. So b squared is 5 squared, minus 4 times 1 times minus 300 gives plus, and this is equal to 1225, which is 35 squared. So therefore our x is minus b plus minus square root of discriminant divided by 2a. A is 1, so it's simply 2. B is 5, it's minus 5 plus minus 35 divided by 2. Again, you can see that one root will be positive and one root is negative, but from physical meaning here we know that our width cannot be negative, so we throw away the wrong solution and only leave the positive one. which is 15, of course, like in the previous case. So we get the same answer, but from a different equation. So width is equal to 15 inches and length is equal to 25 inches. So this is the simplest problem you can solve using quadratic equation. Now let's consider more complicated examples. So the problem number 2 says that there were 45 games played in a chess tournament and every player played each other once. And we need to find the total number of players. So here it's important to understand how the total number of games depends on the number of players. If we say that the number of players in the tournament is X, then it is obvious that every player will have X minus 1 games, because he will have X minus 1 opponents. And this is true for every player. So if we multiply X by X minus 1, we will get the twice total number of games played. Why is it twice? It is because when you do this multiplication, you count each game twice. Indeed, you counted your game against an opponent, and this opponent counted his game against you, which is the same game, but it's counted twice. And this happens to every single game. So this is where this factor of 2 comes from. So the total number of games will be the product of x times x minus 1 divided by 2. So we get our equation. X times x minus 1 is equal to 2 times 45 is equal to 90. We transfer 90 to the left part of the equation. We get the standard quadratic equation, calculate discriminant, like b is equal to minus 1, c is equal to minus 90, a is equal to 1. Discriminant is 1 squared minus 4 times 1 times minus 90, which gives plus again. And it is equal to 361, which is 19 squared. So therefore, our x will be 1 plus minus 19 divided by 2. Again, you can see that one solution is positive and another one is negative. Our number of players cannot be negative, so we only leave the positive solution, which is 1 plus 19 divided by 2, which is equal to 10. So that's our answer. The total number of players in the tournament is 10. See, this equation is very simple here, but here the trick is to understand what is going on and realize that the number of games is equal to x times x minus 1 divided by 2. Okay, now we can consider even more complicated problem, number 3. This problem deals with motion of a boat up and down the river, and the river has a current with a certain speed, and when you travel down the river, the speed adds up to your own velocity, and when you travel up the river, the speed is subtracted from your boat velocity. So our problem is formulated as follows. So our boat, which moves with a constant speed, went 25 kilometers down the river and then 3 kilometers up the river, and it spent 2 hours in total on the travel. The speed of the current is equal to 3 kilometers per hour, and we need to find the boat speed in still water. It's very important to make a drawing here in this sort of problems. It will help you a lot in constructing your equation. So let's say we traveled from this point to that point down the river first, covering 25 kilometers, and then we went up the river covering 3 kilometers, and we spent 2 hours in total on the travel. So, as we discussed, when we travel down the river, the current speed will add up to your boat speed, which we denote as x kilometers per hour. So the speed when traveling down the river will be equal to x plus 3 kilometers per hour. On the other hand, when you travel up the river, your boat speed will be reduced by the current speed. So it will be x minus 3 kilometers per hour. That means that when you travel down the river, the time you spend on the travel will be equal to the distance, 25 kilometers, divided by speed, x plus 3 hours. And when you travel up the river, the time you spend will be equal to distance, 3 kilometers, divided by speed, in this case, x minus 3 kilometers per hour, hours. And we know that the total time is equal to 2 hours, so t1 plus t2 is equal to 2, or this way we get this equation, 25 divided by x plus 3 plus 3 divided by x minus 3 is equal to 2. This equation doesn't look like a quadratic equation at the first sight. It is actually a rational equation. Rational equation, by definition, is an equation containing at least one fraction whose numerator or denominator or both are polynomials. Polynomial is a function of this kind. We will not discuss it in detail now, but in case of a linear polynomial or a function which is equal to the free term plus a term proportional to x, which in general can be written as a plus bx. This rational equation can obviously be reduced to a quadratic equation. Indeed, when you simplify this expression, the highest power of x which will emerge will be the second power. So you will not get a third or fourth power of x here. This kind of rational equations containing numerators or denominators linear with respect to x can always be reduced to a quadratic equation. So now let's solve it. So first we need to simplify this expression. We do cross multiplication in order to have one numerator and one denominator. For this we need to multiply 25 by x minus 3 and multiply 3 by x plus 3, and then our common denominator will be x plus 3 times x minus 3, and it's equal to 2. So you might think that the next step would be just multiplying both parts of the equation by x plus 3 times x minus 3. And this way, after simplifying this and transferring all terms to the left side of the equation, we would get a proper quadratic equation. However, this is not correct, and that's an important feature about rational equations, because here you're losing a condition that your denominator can't be equal to 0. So, which means that x cannot be equal to 3 and x cannot be equal to minus 3. Otherwise, this expression will not make sense, because you cannot divide by 0. And if by solving this equation you would obtain roots which would be equal to 3 or minus 3, it would be a problem. So the proper way to solve equations in general is always to transfer all parts of the equation to the left hand side, leave 0 on the right hand side, and only then do all the further transformations. So we need to multiply minus 2 by x plus 3 times x minus 3. Then we have a common denominator, and we have 0 at the right side of the equation. And now we can say that with the condition of x not equal to 3 and x not equal to minus 3, our equation will be reduced to our numerator is equal to 0. So we just need to keep this in mind, that x is not equal to 3 and x is not equal to minus 3, and we just need to solve this equation now. So you can simplify this yourself by opening brackets, and this is when we add terms with x squared with x and free term. This is what we get. Now we can see that it's all proportional to 2, and it's better to have a positive coefficient at x, so we divide the equation by minus 2, and this way we get this final equation which we need to solve. X squared minus 14x plus 24 is equal to 0. Again, this is our equation, this is our condition that x is not equal to 3 and to minus 3. But we have an extra condition from the physical meaning of our problem. Because x is a boat speed, it obviously should be greater than 0. So in case if we will get a solution of x equal to minus 3, we will throw it away anyway. Another condition is that the boat speed up the river is greater than 0. Otherwise, your boat wouldn't be able to reach that 0.3 kilometers up the river. That means that x minus 3 is greater than 0, or x is greater than 3. So therefore, we can say that our conditions that x is not equal to 3 and minus 3 should always be fulfilled for physically meaningful solutions of our equation. So now we can solve this equation with the condition of x is lesser than 3. Like before, we calculate discriminant, which is b squared, 14 squared minus 4 times 1 times 24, which is equal to 196 minus 96, so 100, which is 10 squared, and then our x will be 14 plus minus 10 divided by 2. So we have two solutions here. One solution is 12, another solution is 2. But we know that our x must be greater than 3. Therefore, we reject this solution, and our answer is 12 kilometers per hour. So the boat speed in still water is 12 kilometers per hour. So this is what we were asked to find. Problem solved. Now let's consider the next problem, which is also a motion problem, formulated as follows. A cyclist went from point A to point B with some constant speed and came back with a speed larger by 5 kilometers per hour. And what was the initial cyclist speed if his average speed was 12 kilometers per hour? As always, it's important to make a drawing to understand what is going on. So this is what is happening. Our cyclist starts from point A and travels to point B with a speed of x kilometers per hour. And then he comes back from B to A with a constant speed of x plus 5 kilometers per hour. And its average speed was 12 kilometers per hour. And we need to find x, which is the initial cyclist speed. First, we need to remember the definition of the average speed. The average speed, by definition, is total distance divided by total time. So if you cover a certain distance in time and divide this distance by time, you will get your average speed. That's the definition. In our case, the total distance is L plus L, which is 2L, and our total time is t1, which is the time which is needed to get from A to B with speed x, and plus t2, which is time which is needed to get from B to A with speed x plus 5. So this time t1 is obviously equal to this distance, which we don't know, but we denote it with letter L. So this distance L divided by speed x. And on the way back, time will be equal to the same distance L divided by x plus 5. So therefore we can say that our total distance is to L divided by total time, which is L plus x plus L. So therefore we can say that our average speed, which is equal to 2L divided by t1 plus t2, which is L divided by x plus L divided by x plus 5, is equal to 12, which is the average speed. So this is our equation. Well, there are two unknowns here, x and L. But we can see that we can divide both numerator and denominator by L, and then L cancels out. And our equation is reduced to this form, where there's only one unknown x. Again, we need to simplify it as much as possible. Since both left and right part of the equation are even, we divide it by 2, we get this equation, and then we transfer 6 to the left hand side of the equation, so there is 0 on the right. It's always good practice when solving equations. And then we first simplify denominator by cross multiplication. So x plus 5 plus x divided by x times x plus 5. And then, since it is 1 over this, what we do, we simply flip over this fraction so that our denominator becomes a numerator and our numerator becomes denominator. So we still need to subtract 6 from this. We do cross multiplication again, 6 times 2x plus 5, then we have a common denominator 2x plus 5, and we open brackets here. And now we get an equation in the form of numerator divided by denominator is equal to 0. As we know, our condition will be that denominator is not equal to 0, and then numerator is equal to 0 will be our equation. So this will be our equation under the condition that x is not equal to minus 5 divided by 2. But again, if we come back to the physical meaning of x, which is the speed, which cannot be negative, therefore this condition will always be fulfilled. So we simply need to solve our equation, and our condition for the roots will be x is greater than 0. So that's what we do here. This is again our equation. We open the brackets and group terms with x squared, x, and three terms together. We get this equation: x squared minus 7x minus 30 is equal to 0. We calculate discriminant: b squared, b is minus 7, minus 4 times a, which is 1, times c, which is minus 30. Minus by minus gives plus. So 49 plus 120 is equal to 169, which is 13 squared. Therefore, our x is minus b plus minus square root from discriminant, or 7 plus minus 13, divided by 2a. A is 1. Again, we can see that there is one positive root and one negative root, which we reject. Therefore, our answer is 7 plus 13 divided by 2 is 10 kilometers per hour. Problem solved. The next problem is problem number 5. So this is not a motion problem anymore. That's a problem which deals with concentration of materials in an alloy. So an alloy of gold and silver contained 40 grams of gold. After adding 50 grams of gold, the concentration of gold in the new alloy increased by 20%. How much silver was in the alloy? As always, it's important to make a drawing here. So initially, we had this alloy containing gold and silver, and we know that there was 40 grams of gold initially and unknown amount of silver, which we denote with x gram. So then our total mass of our alloy was x plus 40 gram, and therefore the concentration of gold was 40 divided by x plus 40, which is mass of gold divided by total mass, which gives you gold concentration. After adding 50 grams of gold to this alloy, we get 90 grams of gold, obviously here, and still the same amount of silver. And we know that the concentration of gold in the new alloy is 20% higher than the concentration of gold in the old alloy. So what is the concentration of gold in the new alloy? Our new total mass is mass of silver plus mass of gold, which is x plus 90 gram. And the concentration of gold will be 90 mass of gold divided by the total mass, x plus 90. And we know that the difference between the two concentrations is 20%, or in the way we define the concentration, it's 0.2. It's a fraction of 1 rather than fraction of 100. So we can write down an equation that the new concentration, which is 90 divided by x plus 90 minus old concentration, 40 divided by x plus 40, is equal to 0.2. It's again a rational equation, and we need to solve it in the same way as we solved the equation in the previous problem. Straight away, we can say that our x cannot be equal to minus 40 or minus 90. Otherwise, the denominators will be equal to 0. On the other hand, we know from the physical meaning of the problem that since x is a mass of silver and it is greater than 0, therefore x will never be minus 40 or minus 90. So our condition for x is simply x is greater than 0. So now we do standard simplification. We first transfer all terms to the left part of the equation. We do cross multiplication here. And then we do cross multiplication with 0.2 with this common denominator. And we get our equation where our numerator should be equal to 0. So when you add terms with x squared, x and three terms together, we better simplify it by dividing by the coefficient at x, which is minus 0.2. And then we get the quadratic equation x squared minus 120x plus 3600 is equal to 0. So the easiest way to solve this quadratic equation would not be calculating discriminant, but spotting that if you complete the square here, you will get the following expression. X minus 60 squared will give you x squared minus 120x plus 3600. So it is exactly, this expression is exactly x minus 60 squared. Therefore, it's straightforward to get an answer, which is 60 gram. You can always solve it using discriminants for practice, but in such simple cases it's particularly easy to complete the square and to get an answer straight away. So our final answer is 60 gram, which was the amount of gold in the initial alloy. Problem solved. Now let's come to problem number 6. And it says that there are two cranes unloading a barge. And when they operate together, they do the work in 6 hours. And when they operate individually, it takes 4 hours more for the first crane to unload everything as compared to the time it takes for the second crane to do the work. So the question is, how much time will the first crane need to complete the work? Well, here it's difficult to make a drawing, but we need to understand what is going on. So we need to introduce the speed, the unloading speed of the first and second crane in terms of number of units per hour. So if x is unloading speed of the first crane, which we need to find, and y is unloading speed of the second crane, both in units per hour, and n is the total number of units which we need to unload, then the time the first crane spends on unloading this number of units will be equal to n divided by x. And the time the second crane would need to unload this number of units will be equal to n divided by y. And we know that the difference between these two times is 5 hours. We also know that when the two cranes operate together, they will unload this number of units in 6 hours, which means that the number of units still the same, n divided by x plus y, which will be speed of the first crane plus speed of the second crane, since they work together, and it is equal to 6. So we get two equations. From here we get that n divided by x minus n divided by y is equal to 5. And this equation says that n divided by x plus y is equal to 6. So we get two equations and three unknowns. However, in this case, we don't need to find all the variables. What we are interested in is the ratio of n divided by x. Therefore, we can do some simplifications and reduce the number of variables to 2, as we will do on the next page. But first we need to remember that from physical meaning both x and y should be positive, and from here, since it's a rational equation, x cannot be equal to 0, y cannot be equal to 0, and x plus y cannot be equal to 0, which means that x is not equal to minus y. So we can see that all these conditions are fulfilled for the positive number of parameters x and y. Indeed, x is not equal to 0, y is not equal to 0, and x cannot be equal to minus y, because if 1 is positive, then 1 would be negative, if that would be the case. So now we get this system of equation. We need to find n divided by x. So what we can do with this equation, we can divide both numerator and denominator by n, and we get this expression, 1 divided by x over n plus y over n is equal to 6. And then if we come back to our original notations of t1 and t2, which is equal to n divided by x and n divided by I correspondingly, we can see that x divided by n is 1 over t1 and y divided by n is 1 over t2. So we can rewrite our system of equation as follows. t1 minus t2 is equal to 5, and 1 over t1 plus 1 over t2 is equal to 6. From the first equation, we express t2 as a function of t1, so t2 is equal to t1 minus 5, and from here we get this t1 t2 divided by t1 plus t2 is equal to 6. And if we substitute t2 from here to here, we will get this equation. So that's equation with respect to t1, and that's what we need to find. So what we do, we simplify this expression again, transfer all terms to the left hand side of the equation, then do cross multiplication, 6 times 2 t1 minus 5, group all the terms, so that's t1 is not equal to 5 divided by 2. That's a new condition, so in principle it could be that one of our solutions could be t1 which is equal to 2.5, and then we will have to reject it because this is a rational equation. So under this condition we just solve the equation where our numerator is equal to 0. So this is this equation, t1 squared minus 17 t1 plus 30 is equal to 0. We calculate discriminant, which is 17 squared minus 4 times 30, which is 169, or 13 squared, and therefore our t1 is 17 plus minus 3 divided by 2. So we get two answers for t1. One answer is 15 and another answer is 2. But now we need to look at the value of t2, which would correspond to this t1. And in the first case, t2, which is equal to t1 minus 5, is 10. But in the second case, t2 will be minus 3, which obviously has no sense. So therefore, this second solution, t1 is equal to 2, has no physical meaning, and we only have one solution here. t1 is equal to 15 hours, or the time which is needed for the first crane to complete the work is 15 hours. So that's our final answer. Problem solved. The final problem is problem number 7, and it says that two 3D printers manufactured a certain number of parts in 2 hours and 55 minutes. And we are asked what time would the first 3D printer need to manufacture the same amount of parts if it is known that 2 hours more is needed for the second 3D printer to manufacture the same amount of parts. Again, in this case it's difficult to make a drawing, but we need to understand what is going on before writing any equations. So let the number of parts produced in this problem be n, and then speeds of the first and second printers, we will call it x parts per hour for the first printer and y parts per hour for the second printer. Then the time which will be needed for both printers to produce this number of parts will be equal to n divided by x plus y, and the time needed for the first of second printers to make the same number of parts by themselves will be n divided by x and n divided by y. So we know that the time which is needed for the second printer to manufacture this number of parts is 2 hours more than this time needed for the first printer, or in other words, t2 minus t1 is equal to 2 hours. And we know that when they work together, this time they will need to manufacture this number of parts is 2 hours and 55 minutes. Here it is important aspect that we are giving time in hours and minutes, but our speeds is in parts per hour, our number of units is in parts, so we need to convert hours and minutes to simply hours. So because all the units should always be consistent. That's the very important thing when you solve problems. You first look at the units and you look that it is consistent. You cannot measure your distance in kilometers and speed in meters per second. So if you measure your distance in kilometers, you must use speed in kilometers per hour in times in hours. Or otherwise, you can use your distance in meters, speed in meters per seconds, and time in seconds. But they should all be consistent. Therefore, we need to write this time as time in hours only. So what is 2 hours and 55 minutes? It's 2 and 55 sixtieths of the hour, or 2 and 11 twelfths of the hour, or 35 twelfths of the hour. So now we are ready to write our equations, which will be n divided by x plus y is equal to 35 twelfths, which is a time needed for both of them to manufacture the number of details n, and n divided by y, which is t2, minus n divided by x is equal to 2. Again, like in the previous case, we have 2 equations and 3 variables, but again, we are only interested in ratio of n divided by x or n divided by y. So we can do the same trick as in the previous problem. So we can divide in this equation both numerator and denominator of the left hand side by n, and this is what we get. And if we come back to our original notations of t1 and t2, so this is t2, this is t1, and then we can rewrite our equations in this form. So it's 1 over 1 over t1 plus 1 over t2 is equal to 35 twelfths. So we simplify this, flip it over, we get t1 t2 divided by t1 plus t2 is equal to 35 twelfths. Then we transfer 35 twelfths to the left side of the equation, and then we substitute t2 with 2 plus t1, which we obtained from this equation. And then we get a rational equation with only one variable t1. So what we can do here to simplify it, first we spot that our both denominators are even, therefore we can multiply this equation by 2, and then it will be t1 times 2 plus t1 divided by t1 plus 1 minus 35 6 is equal to 0. And then we can do cross multiplication. Our denominator will be 6 times t1 plus 1. Therefore our t1 cannot be equal to minus 1, but we know that t1 is time, it cannot be negative, so it's always true. So therefore our equation is simply this numerator is equal to 0. When we open brackets and group the terms with t1 squared, t1 and free term, we get this equation. So the solution is simple. We calculate the discriminant, which is 23 squared minus 4 times 6 times minus 35. Minus by minus gives plus. And this is equal to 1369, which is 37 squared. Then our t1 can be equal to 23 plus minus 37 divided by 2 times 6, which is 12. Again, we can see that one root is positive and one is negative. Negative makes no sense because it's time, so we only leave the positive number. and therefore our T1 is 23 plus 37 divided by 12, which is equal to 5 hours. That's our answer. So that's the time needed for the first 3D printer to manufacture this number of details. Problem solved. Thank you for watching.